Section 4.1, solving system of linear equations in two variables. In the next section, we'll try to learn how to solve system of linear equation in three variables. What exactly system of linear equation is? If you take two equations, linear equations, remember linear means the picture of these guys are going to come up as a line. So if you take two equations simultaneously in one single problem, so we have formed a system. So a system consists of two simultaneous equations in terms of x and y, but they have to be linear. In other words, the powers of x and y have to be 1. They have to be equal to 1. So that means the graph, linear means the graph of these guys are going to come up as a straight line. So this is an example of system of linear equation in two variables. So is this guy, so is this guy. So now the question is, what is the solution? What kind of answer do we get for these kind of equations? Turns out the answer is rain or shine, an ordered pair of numbers, such that the components of this ordered pair has to satisfy what? Both of these equations, both equations, not just one, but both. For instance, let's say the question is verify if what? Ordered pair 2, 1 is a solution to the system. Remember, we call it ordered pair because the order matters. X has to go first, followed by y. And it's pair of numbers. And we always use parentheses. Do you see it? So to check and see if this is the solution, we replace the x's with 2, y's with 1. Here we get 2 plus 1, which is 3, but that's not good enough. We also have to check equation number 2. Is 2 minus 1, 1? Yes, it is. Checks. However, in next problem, the ordered pair is given to us as -3, 0. Is that the solution for this system? Notice if you replace x's with -3 here and y with 0, you get -9, which checks equation number 2. However, if you replace x with -3 here, y with 0 here, it doesn't add up to -8. Therefore, even though this ordered pair, the components of this ordered pair satisfied equation number 2, but it didn't satisfy equation number 1. So therefore, the conclusion is no. That's not a solution. With that said, now the next question is, how do you solve these kind of equations, system of linear equations in two variables, and what are the methods available? Well, some of you might have known from previous class, which we have three methods available for system of linear equations in two variables, namely graphically, substitution, elimination. Some people call it addition method. And I put a little star here because this is the most popular way of solving what? This kind of equations. What do you say we try solving few equations, system of linear equations in two variables with what? Graphically. So that means I have to graph this. Remember in previous chapter 3, we learned the best way to graph the line is what? Put the equation in the slope-intercept form and graph them. So these are standard forms. So if you kind of isolate the equations for y, you would put them in the slope-intercept form. Notice if the coefficient of x is not visible, by default that means 1. So that means the slope of this line is 1, the y-intercept is -3. The slope of this equation number 2, the graph of equation number 2 is -1, y-intercept is 1. So let's graph these guys and see how the lines look like. All right, so I'm gonna go -3, which is the y-intercept, but the slope is 1/1, so I'm gonna go up 1/1. Then I'm gonna graph what? This line here, do you see it? Okay, so that would be the picture of equation number 1, right? And I'm going to do similar type of procedure to graph draw a picture of equation number 2. The y-intercept is 1, but the slope is -1, which means I have to go down 1 over 1. And now I have to kind of connect the dots here. And lo and behold, this would be the picture of equation number 2. If the system has a solution, then the pictures have to cross each other at a single point. Notice, in this case, the system has a solution, and the cross intersection of these two lines happens to be, notice if we go up, it's 2. If we go to the left on the y-axis is -1. So by inspection of my graph, notice this corresponds to 2 on the x-axis, corresponds to -1, this point of intersection on the y-axis. So I would say the solution is 2, -1. Because we had a solution, then the system is called consistent, or some people call it independent system. So whenever the lines cross and you end up with a solution, then the system is either called consistent or independent. Now let's take a look at the equation, system, system of linear equation number 2, example number 2. If you put these two equations in the slope-intercept form, you get these, okay? So the first one is there is no y-intercept, so the graph goes through the origin, but the slope is 1/2, so I gotta go up 1 over 2, and then this would be the picture of equation number 1. You see it. Okay, equation number 2, the y-intercept is 4, there it is, but the slope is 1/2, so that means I gotta go up 1 over 2. And when I graph that, I get what? This guy, which is right over here. Notice the lines did not cross. If the lines don't cross, so we have no solution. Why? Because the lines did not cross. So what is the system called? Inconsistent. Inconsistent system, correct? So if the lines don't cross, that means they are parallel because they have same slopes. So there is no solution and the system is inconsistent. On the other hand, let's take a look at equation number 3, problem example number 3. So if you put equations 1 and 2 in the slope-intercept form, that's what you get. In this case, the y-intercept for equation number 1 is -2, slope is 2/5. So I have to go up 2 and 5 over. When I do, I get this line. Do you see it? Okay. Now, if I do, this is equation, the graph of equation number 1. For equation number 2, notice it's identical to equation number 1. So that means the graph of equation number 2 overlaps with equation number 1. So they happen to be on top of each other. So in this case, we say the system is called dependent. So we have dependent system. And we have what? Infinite many solution. That means we have millions of solutions. Where are those solutions? Any order pair you select on this line would serve as a solution to the system. So the system is called dependent. So in cases like this, just write the final answer as what? A dependent system, that's all. Finally, this guy, so if you put once again equations 1 and 2 in what? Slope-intercept form. The first guy has a y-intercept of -1 and the slope is -2, so that means I gotta go down 2 over 1, so I have to graph this line here. Do you see it? So that would be equation number 1. So this is the picture of equation number 1. Number 2, the y-intercept is 2. Slope is -1/2, so I got to go down 1 over 2. And if I graph this guy, I would get this line. Notice once again, they do intersect at this point. Where exactly that point is, by inspection, notice if I go down, x is -2. If I go over till I hit the y-axis, y is what? +3. Therefore, the solution is what? Is -2, 3. So the system is called consistent. Is that right? Consistent. Or some people call it independent. And we have one-of-a-kind answer. Do you see it? All right. So that's graphical. So you got to have an accurate graph. The next method is called substitution. Remember, substitution means what? Replacement. You know, when you say, oh my goodness, today we have a substitute teacher, that means someone is going to replace my original teacher. In these kind of scenarios, take a good look at the equation and see which one has been solved for y. If either equation has been solved for a specific letter, take that. In this case, notice y is equal to 2x plus 6. So I'm going to take equation number 2 and substitute it in equation number 1. What does that mean? I'm going to go to equation number 1, right? Wherever I see y, I'm going to replace it with what? 2x plus 6. Because in equation number 2, y happens to be equal to 2x plus 6. Or put it this way, go to equation number 1 and replace the y with 2x plus 6, or substitute. When you do, you get this. So now, if you remove the parentheses, you get what? 3x minus 4x minus 10, minus 12 is equal to -7. So minus x minus 12, -7. So minus x is equal to what? 5. So x is equal to what? -5. That's not good enough because now we got to go find y. Question is, you can either go from equation number 1 or equation number 2, find what? Y. I'm going to go to equation number 2 because y is on one side of the equation. So I'm going to replace the x with -5. So I'm going to get 2 times -5 plus 6. So that's going to be -10 plus 6, which is -4. Well, we are not going to write our answers, you know, separately. We're going to kind of group them, pair them up. Remember, x goes first, followed by what? Y. There it is. That's the final answer. Do you all see it? Final answer. Question is, what if one of the equation is not solved for a specific variable? Well, in that case, pick your favorite equation and solve that equation for your favorite what? Letter. In this case, notice neither of the equations are what? Solved for x or y. So I'm going to take equation number 1. Remember, you could have taken equation number 2, but I'm going to always look for an equation which is easier to solve for. Because x doesn't have a coefficient, so I'm going to take equation number 1 and solve this equation for x. How am I going to do that? Move the -5 over. So now you have +5y minus 8. Call that equation number 3. Where did 3 come from? It came from 1. So it cannot go back to 1. It has to go back to 2. So in equation number 2, replace this x with 5y minus 8. Okay, remember this came from 1, so it has to go into 2. So go back to equation number 2, replace this x with 5y minus 8. Now you have one equation, one unknown, so it's possible to solve. Okay, so that's 15y minus 24 minus 2y equals -11. So that would be like 13y is equal to what? Is 13. So y is equal to 1. So now go back to equation number 3 because that's the one you solved for x. Replace the y with 1. So lo and behold, x is equal to -3. So the solution is -3 comma 1. Final answer. Notice the answers should show up as an ordered pair. Do you see it? So finally, we have elimination or addition method. Once again, I'm sure most of you have seen this. So I hope that this is a review from previous class. Elimination means if you add up the equation, you would hope and pray to God that one of the variables will disappear. So if I add equation number 1 to 2, notice negative x plus x adds up to 0. Usually we cancel them out, so that means they add up to 0. But positive y minus 2y adds up to negative y. And 4 plus 6 adds up to 10, so therefore y is equal to -10. Do you see it? Y is equal to -10. So I was lucky. The minute I add the equations, that means I combine the like terms on the left side and set it equal to combining the numbers on the right side, and lo and behold, what do you know? X is my luck, disappeared. So I got the y, right? But now that's not good enough. I have to go find out what x is. How would I do that? Your choices are either equation 1 or 2. Let's go to equation number 2, which says x minus 2y equals 6. But you already got what y is, so go like x minus 2 negative 10 is equal to 6. That's x plus 20 equals 6. So x is equal to -14. Do you see it? But remember, we are going to write the answer as an ordered pair of numbers. X goes first, followed by y, and the answer, rain or shine, shows up inside the parentheses. Final what? Answer. Do you see it? Sometimes we are not lucky as the previous example, and when you add, neither x's nor y's disappear. So now you have to come up with the smart way of what? Eliminating either x or y, whichever, it doesn't matter. So let's say I decided to wipe out the x's. You know what I'm going to do. I'm going to multiply both sides of equation number 1 by this number, 5. Okay? Then I'm going to look at the coefficient of x on top, and I'm going to multiply both sides of this equation, both sides, by 2. So that way, when I multiply 5 times 2 is 10x, 2 times -5x is what? -10x, so the x's when I add the equations add up to 0. You could have what? Eliminated the y's, multiply the top both sides, let's say by 3, multiply the bottom by, let's say, what, 7, and there you can eliminate y's. So you gotta decide which variable is it you like to eliminate, then go from there. I decided to eliminate, it was just a preference, eliminate x's. So that's what I did. I multiplied the top equation by this coefficient, the bottom equation by that coefficient, but make sure they end up with opposite what? Signs, otherwise they won't get canceled. Anyways, if you multiply the first equation by 5, both sides, you get 10x minus 35y is equal to 15. You multiply both sides of equation number 2 by 2, you get negative 10x plus 6y is equal to 14. Do you all see it? Now, when you add these equations up, that means you combine the like terms on the left. These guys add up to 0. And these guys would be negative 20y is equal to what? 15 plus 14 is 29. So remember, that's what we mean by add the left side and the right side. And that in turns means add up the equations. When you divide both sides by negative 29, lo and behold, y is equal to -1. Do you see it? So the question is, which equation should I go to find x? It really doesn't matter. Here, here, there and there. You have 4 possible spots to go and find what? X. I'm going to go to equation number 1, which said originally 2x minus 7y is equal to 3. But I already got the y, negative 1, so I'm going to replace the y with negative 1. And I'm going to say this is 2x plus 7 is equal to negative 3. So 2x equals negative 4, so x equals negative 2. But keep in mind, we can't write the answers, in isolation. You have to pair them up using what? Parentheses. Remember, x goes first, followed by y. And this would be our what? Final answer. You see it? All right. Thank you.